We think of public transportation as this great equalizer, right? The thing that gets everyone around. But what if the system itself has hidden biases built right into the map? Today, we're going to dig into an amazing study from Kalamazoo, Michigan, that used data to find those invisible gaps and figure out how to fix them.
I mean, we've all been there, haven't we? You look up the bus route, and the nearest stop is a 20-minute hike away. Or maybe the bus just doesn't go where you need it to at all. It's annoying for sure, but for a lot of people, that frustration is a real barrier. A barrier to getting a job, to education, or even just making a doctor's appointment.
And this map right here, it illustrates the problem so perfectly. The blue dots, those are their traditional fixed bus stops in Kalamazoo County. You can see they're all kind of clumped together. But the red dots, the red dots are where people actually requested a ride from an on-demand service. The disconnect is just, wow. You can see it immediately. A huge sea of red in places with no blue in sight. So this gap, this space between you and the bus, it actually has a name. It's called the first mile/last mile problem. It's that critical distance from your front door to the transit network, and it's exactly where public transit so often breaks down. And the study we're looking at, well, it didn't just want to talk about this problem. It set out to measure it with real data. All those red dots on the map came from something called Demand Responsive Transit, or DRT for short. The easiest way to think about it is like a public shared Uber or Lyft. It's not stuck on a fixed route, it's flexible. It goes where people need it, when they need it. And this idea is going to be a really key part of the solution. Okay, so the researchers had the problem in one hand and a potential solution in the other. Now it was time to get to work. They had to figure out a way to turn that messy map of red and blue dots into a really clear data-backed picture of who exactly was being left behind by the old bus system. Which is a great question, right? How do you actually measure a gap like that? You can't just guess. You need a consistent, systematic way to define what it even means to be served by public transit. And that's where their first analytical tool comes into play. They used a technique called buffer analysis. It's a really simple concept, but it's super powerful. Basically, they just drew a circle, a buffer, around every single bus stop on the map. That circle represents what you might call a reasonable walking distance. If you're inside one of those circles, you're covered by the system. If you're outside, you're not. And here's what it looks like when you put it all together. They took all those individual circles and merged them into this one big purple zone. So this is the official service area for the entire fixed-route bus system according to a standard half-mile walk. Now, this graph shows you just how much that reasonable walking distance matters. It shows the percentage of trips that are unserved based on how far you're willing to walk. Check it out. If you can only manage a tenth of a mile, more than 55% of all ride requests are out of reach. Even at that half-mile standard, a huge percentage of trips are still totally unserved. And that analysis brings us to this big headline number, nearly 23%. Even using a pretty generous half-mile definition of walkable, almost a quarter of all on-demand ride requests started in what you could call a transit desert, completely outside the reach of the bus system. Let me put that another way. More than 1 in every 5 people who needed a ride were basically stranded by the existing map. So knowing that 23% of trips are unserved, that's a big deal. But it's still just a number. For a city planner, you need to know where those people are. You need to find the hidden hotspots of unmet demand. I mean, if you look back at that first map with all the red dots, it's just a cloud. It's pure noise. How on earth do you find the real patterns in there? How do you turn that chaos into a clear map that tells you where to focus? Well, you use a really smart algorithm. They use an algorithm called dbScan. I love this. You can think of it as a smart highlighter for a map. Instead of a person trying to guess and draw circles, this algorithm automatically finds the places where the data points are really dense, groups them together as a cluster, and just ignores all the random scattered points. And voila, here's the result. This is a total game changer. That messy cloud of points has been totally transformed into these clean, color-coded clusters. Each one of those colored blobs is a hotspot, a specific neighborhood with a significant, concentrated need for transit that the current system just isn't meeting. All told, the algorithm found 27 of these distinct clusters, 27 real, definable transit deserts where this problem isn't just an idea, it's a daily reality. But knowing where the gaps are is only half the story. The next, and maybe most important step, was to figure out who lived in them. And this, for me, is where the study goes from just being clever to being truly powerful. because they didn't just stop at finding the hotspots. They understood that not all demand is created equal. A trip to go shopping is important, sure, but it's not the same as a trip for life-saving medical care. They knew they had to bring the human element back into the equation. This quote from the paper just says it all. The goal wasn't just to find the busiest spots. It was to understand where the need was the greatest. And to do that, they built their own custom scoring system to rank those 27 clusters. So their priority score rested on 4 key things. First, of course, was trip volume. How many people actually need a ride? But then they layered on 3 crucial factors about the people living there. What's the median income? What's the poverty rate? And what percentage of the population has a disability? This totally shifts the focus from just efficiency to real equity. And these maps visualize that overlap perfectly. You can see how the clusters of ride requests, the colored dots here, are often concentrated in the very same areas that have lower incomes or higher rates of disability. This is no coincidence. It's proof that transit gaps hit the most vulnerable people the hardest. All right, so now they have all the pieces. They know where the gaps are, they know who is being affected by them, and they know which areas are the most critical. The last step was to put it all together into a simple, actionable blueprint that the city could actually use to make a real difference. And here it is, boiled down into a simple table. This shows their top-ranked priority zones. So look at Cluster 27. It has the most trips, sure. But now look at Cluster 15. It has way fewer trips, but it also has high poverty and the largest population of residents with disabilities. This is what makes the data so powerful. It shows that you don't just send buses to the busiest places, you send them where they'll do the most good. The data also revealed when people need help the most. This graph is fascinating. It shows 2 huge spikes in demand on weekdays, one right around 8 a.m. and another around 2:30 p.m. It doesn't take a genius to figure that one out. That's people trying to get to work and parents trying to pick up their kids from school. These transit gaps are directly impacting people's livelihoods. So in the end, the blueprint for action becomes crystal clear. You deploy those flexible, on-demand services directly in the top-ranked clusters. You make sure they're running during those morning and afternoon peaks. You focus on solving that first mile/last mile problem. And maybe most importantly, you make this kind of data-driven, equity-focused analysis a permanent part of how you plan transit from now on. This whole study just goes to show when you combine the right data with a real focus on people, a city can go from just running bus routes to actually serving its community. And it leaves you with a really big question to think about. What hidden patterns and invisible gaps are just waiting to be discovered in your own city?